And now, last but certainly not least, robot design.
So our robot. So we kept the basic build of the robot and just added several attachments. Our first attachment is the half of a claw. We use this to pour down the bochi cubes, and that's how we complete that mission.
It is controlled by the medium motor.
And then we have our second attachment. This is used to carry the 4 cubes and the innovation project into the 4 hopscotch squares inside our bench mission.
So this is a passive attachment, meaning it uses no extra motor.
This attachment drops the remaining cubes into the bochi. So it uses the medium motor and it lowers it.
And this is our fifth attachment that's using the step counter. It's a passive attachment because it doesn't require a motor, and we use it to the step counter mission.
Strategy and innovation. Our main mission was
To complete as many missions as possible in a timely and efficient manner to the best of our abilities.
and we broke this down into several objectives.
Our first objective was to complete several missions in one run. Our second objective was to use as many sensors as we could, and our third objective was to make the code more reliable, and our last objective was to integrate everybody's ideas.
To accomplish this, we used several strategies.
We give everyone time to work on the robot, but we planned together as a team. We researched a lot. We found out what works and what doesn't, and then after, we kept notes of tips and tricks that we learned along the way.
We implemented different tactics as well.
We wrote on whiteboards to keep track of the tasks. We wrote deadlines as well as work on teams of 2, and we rotated the roles. We then used the engineering notebooks and documents to track our work.
Order of completion. We would do the bench, step counter, bochi, treadmill, innovation project, under the pull-up bar, and then we would finish with dance party.
Why that order? Convenient due to certain attachments, compatibility. We decided to complete these missions in a particular order because they would be more convenient due to the certain attachments. For example, we placed a small cube attachment at the back of the robot so we could save time by not having to attach it. Some attachments that we had were not compatible with the cube, so we decided to first complete the missions in which the attachment could not be affected by having an extra part sticking out.
Using sensors. So we decided to use the gyro sensor, which helps our robot move in a perfectly straight line. We saw that the robot had trouble with this, and sometimes it would veer off course, causing the robot to not be able to complete the mission reliably. Resetting the gyro sensor helped make the code a lot more precise and accurate, as did the block right above that, called set movement motors to hold position at stop. This means that even if it's moved slightly, the robot moves slightly, the motors will move back to the original position that they stopped in. And the negatives that you see just mean that we wanted the robot to go backwards.
For most of these, the rotations were wrong. It took a while to find the perfect number since it would change when we positioned the robot incorrectly. The gyro sensor we use now prevents mistakes like these. The robot cannot go off course anymore. Our next step is to incorporate more sensors, like the color and ultrasonic sensor.
Final code. We set our movement motors to A and D in all the codes because with or without it, the robot wouldn't run at all. We also decreased the robot speed by 40% because it would allow the robot to move slower and be more carefully when completing missions. We used the gyro sensor forward 5 times. We reset all our motors, same as when we reset the tire pressure sensors on our cars before it became dangerously misleading. It also allowed us to be more accurate. We used the weight block so we could change attachments and reposition our robot.
Thank you for watching. We'll see you back at SCDC TV. Have a great day.